In the vast, sprawling theater of our solar system, there are stars, planets, asteroids, and comets. And then there are the moons. Hundreds of them. But not all moons are created equal. Some are just tiny rocks captured by a planet's gravity. Others are giants in their own right. And then there is Ganymede. This isn't just any moon. Ganymede is the undisputed king of moons. It's the largest moon in our entire solar system. Think about that for a moment. It orbits the biggest planet, Jupiter, as if to say, only the best for the best. Its sheer scale is hard to comprehend. It's a world unto itself, a celestial body that challenges our very definition of what a moon can be. How big is big, you ask? Let's put it in perspective. Ganymede is larger than the dwarf planet Pluto. But that's not even the most mind-blowing part. Get this. Ganymede is bigger than the planet Mercury. That's right, a moon that's bigger than a full-fledged planet. If Ganymede were orbiting the Sun instead of Jupiter, we would call it a planet without a second thought. Its massive size gives it enough gravity to pull itself into a perfect sphere. It's a cosmic heavyweight, a testament to the wild and wonderful variety of objects that populate our universe. It's a place that demands our attention and sparks our cosmic curiosity. Ganymede is part of an exclusive club. It's one of the 4 Galilean moons, a quartet of celestial wonders discovered by Galileo Galilei back in 1610. When Galileo pointed his primitive telescope at Jupiter, he saw not just the planet, but 4 little stars dancing around it. These were Io, Europa, Ganymede, and Callisto. This discovery was revolutionary. It showed that not everything in the heavens revolved around the Earth. It was a major crack in the old geocentric model of the universe. Ganymede, as the biggest of this group, stands as a monument to that incredible moment of scientific awakening, a turning point in human history. These 4 moons are like a miniature solar system orbiting Jupiter. They are all fascinating worlds. Io is a volcanic hellscape, the most geologically active object in the solar system. Europa is a smooth, icy ball that likely hides a global ocean. Callisto is an ancient, heavily cratered world that looks like it hasn't changed in billions of years. And then there's Ganymede, the giant. It shares characteristics with its siblings, but also has unique features that set it apart. It's a complex and dynamic world, a place where many of the universe's most exciting processes are on full display, waiting for us to explore and understand. So what's going on inside this behemoth moon? If you could slice Ganymede in half, you'd see a world with layers, much like Earth. At its very center, scientists believe there's a metallic core, likely made of iron. This spinning molten core is the secret to one of Ganymede's most amazing features, which we'll get to later. Surrounding this core is a rocky mantle, but the most exciting part lies above that. Evidence from NASA's Galileo and Hubble spacecraft points to something truly spectacular, a deep salty ocean. This isn't just a small pocket of water, it's a vast, global ocean hidden beneath a thick crust of ice. This hidden ocean is a game changer. It's estimated to be about 60 miles deep. For comparison, the deepest part of Earth's ocean, the Mariana Trench, is only about 7 miles deep. This means Ganymede might hold more water than all of Earth's oceans combined. And where there's liquid water, there's a question that gets every scientist's heart racing. Could there be life? This saltwater ocean, protected from space by a thick shield of ice, and potentially warmed by the moon's core, could have the necessary ingredients for life to emerge. It makes Ganymede one of the most compelling places to search for extraterrestrial biology. On top of this vast ocean is a thick, frigid crust of ice. This isn't just a simple sheet of ice, though. It's a complex geological layer that tells the story of Ganymede's history. The ice is likely hundreds of miles thick in total, a formidable barrier between the hidden ocean and the vacuum of space. The dynamics between this icy shell and the ocean below are a major topic of study. Is the ocean in direct contact with the rocky mantle below? If so, chemical reactions could provide energy for life, similar to hydrothermal vents on Earth's ocean floor. It's a tantalizing possibility, but that's not all. Ganymede also has an atmosphere. Now don't get too excited, you couldn't breathe it. It's incredibly thin, what scientists call a tenuous atmosphere. And it's made primarily of oxygen. This oxygen isn't produced by life, like trees on Earth. Instead, it's created when charged particles from Jupiter's powerful magnetic field slam into the icy surface. These particles break the water ice into hydrogen and oxygen. The lighter hydrogen gas escapes into space, while the heavier oxygen atoms linger, forming that thin atmospheric veil. It's a fascinating process, a form of cosmic chemistry happening right before our eyes. When you look at pictures of Ganymede, you immediately notice that its surface is not uniform. It's a patchwork of different terrains. You see large areas that are dark and other regions that are brighter. These two distinct types of terrain tell a story of a long and violent history. The dark regions are the older parts of Ganymede's surface. They are covered in countless craters, evidence of a heavy bombardment by asteroids and comets that happened billions of years ago. These areas are like ancient, weathered landscapes, preserving a record of the solar system's chaotic youth. They are a history book written in scars. In stark contrast, you have the lighter terrain. These areas are younger and less cratered, but they are far from smooth. They are crisscrossed by a complex network of long grooves and ridges. These features suggest that the moon's surface has been pulled apart and shifted around. It's a sign of tectonic activity, but not like the plate tectonics we have on Earth. On Ganymede, it was likely driven by processes in its icy crust, perhaps as the subsurface ocean expanded and contracted. These grooved terrains cover about 2/3 of the moon's surface, indicating a massive geological upheaval in its past that resurfaced large portions of the world. The craters themselves add another layer to the story. Some of them look fresh and sharp, with bright rays of ejected ice spreading out for hundreds of miles. These are the marks of more recent impacts. Other craters look old and degraded, almost like they are melting back into the surface. This is because ice, over geological timescales, can flow and deform, causing old features to soften and fade. This process, known as viscous relaxation, gives the oldest craters on Ganymede a ghostly, flattened appearance. It's a slow-motion geological process, turning sharp impacts into gentle depressions over eons. And then there's the evidence of a really bad day in Ganymede's past. Scientists have found evidence of a colossal impact. Long ago, a massive asteroid or comet slammed into the moon. The impact was so huge, it didn't just leave a simple crater. It sent shockwaves rippling through the entire icy crust, creating a series of concentric rings that stretch across a huge portion of the moon's surface. This feature, known as a palimpsest or ghost crater, is a faint scar of an ancient cataclysm. It's a dramatic reminder of the violent events that have shaped the worlds of our solar system, Ganymede included. Now, for Ganymede's most unique and astonishing feature. It's the only moon in our solar system known to have its own magnetic field. That's a big deal. Planets like Earth, Jupiter, and Saturn have magnetic fields generated by their molten cores. But for a moon to have one is extraordinary. This magnetic field, or magnetosphere, is generated by the convection currents within Ganymede's liquid iron core. It acts like a protective bubble, shielding parts of the moon's surface from the constant barrage of high-energy particles trapped in Jupiter's much larger and more powerful magnetic field. It's Ganymede's personal force field. This magnetic field doesn't exist in a vacuum. It's embedded within the colossal magnetosphere of Jupiter, which is thousands of times stronger. This creates a complex and fascinating interaction. It's a magnetic field within a magnetic field. As Jupiter's field lines sweep past Ganymede, they connect and clash with the Moon's own field. This interaction funnels energetic particles down toward Ganymede's poles. And what happens when charged particles hit an atmosphere? You get auroras. That's right. Just like the northern and southern lights on Earth, Ganymede has its own auroral displays, shimmering curtains of light at its poles. The behavior of these auroras provided a key clue to what lies beneath the ice. Scientists using the Hubble Space Telescope observed that the auroras on Ganymede don't wobble as much as they should. The magnetic field interaction with Jupiter should cause them to rock back and forth significantly. The fact that they don't suggests there's a counteracting force at play. The best explanation is a global layer of electrically conductive material. And what's a great conductor that Ganymede has in abundance? Salt water. The hidden ocean, by interacting with Jupiter's magnetic field, creates its own secondary magnetic field that dampens the rocking of the auroras. It's cosmic detective work at its finest. So why should we care about this giant icy moon so far away? Because Ganymede is a cosmic laboratory. It's a world of superlatives, the biggest moon, the only one with a magnetic field, and a potential ocean world. It challenges our ideas about where the conditions for life might exist. It shows us the incredible diversity of worlds in our own solar system. For scientists, it's a treasure trove of data about planetary formation, magnetic fields, and potential habitats for life. For the rest of us, it's a source of wonder and inspiration. It's a reminder that the universe is full of incredible places, just waiting to be explored. Keep looking up.